Adding and subtracting. So the first thing we're going to do with complex numbers is adding and subtracting. This is subtracting, so you want to make sure you pay attention to your negatives. So you can use subtraction, or you can just change this to adding the opposite, whichever you like to do better. So if you change this to adding the opposite, you need to make everything inside here the opposite of what it was. Right, so combining my like terms, I have -2 plus a -6, which gives me -8. And then I have -5 plus a +2, which gives me -3i. And that would be my answer. So don't distribute here. Think of this as -2 minus 5i. And if you changed it all to addition, you can say plus a -6 plus 2i. You're not distributing. You are just combining like terms. The only time you distribute is if it was butted up next to each other and there was nothing in between, and then you would multiply across.
So it's just...
Next thing we did was multiplying. If you see something that looks like this problem right here, it just means multiply it by itself. So you're going to say -7 plus 2i times -7 plus 2i. This is where you're going to distribute. So we're going to say -7 times -7, -7 times 2i, 2i times -7, and 2i times 2i. This is also where you will get an I squared, which you need to simplify. Remember, I squared is -1, so it's going to change this to just -4. All right, and then you can combine your like terms. 49 minus 4 is 45, and -14 minus -14i is -28i, and that would be your answer. All right, the last thing that we did with imaginary numbers was division, or rationalizing. And so you are going to want to rationalize here using the denominator. Rationalize by using the conjugate of the denominator. So I'm going to take this problem and I'm going to look at my denominator, and I'm going to rewrite the denominator, and I'm going to change the second sign to the opposite. So it was -1 minus I, it's going to become -1 plus I. That is what I'm going to multiply by. And I will multiply the top and the bottom by that group. On the top, you can just distribute, just like FOIL, just like we've done. So 3 times -1, 3 times I. Then 5i times -1, and 5i times I. In the denominator, this is a special case, a plus b, a minus b, right? So we just square the first one. -1 squared is just 1. Always use subtraction. And then square the second one. I squared is I squared. All right, so we're going to change our I squareds to -1, right? So plus 5i squared is -5. Negative I squared here is +1. Okay? And now we can combine our like terms here. -3 minus 5 is -8. 3i minus 5i is -2i. And that is all over 1 plus 1, which is 2. And remember, we can separate these, right? -8 over 2 minus 2 over 2i. And here you can see you can reduce this, right? Like I can reduce this, right? -8 over 2 is -4. -2 over 2 is -1i. Or you can just say -4 minus I, since it's a 1 in front of it. So this is a multi-part question, meaning you will get a point for the axis of symmetry, a point for the vertex, a point for the y-intercept, and a point for the graph itself. All right, this is a 4-point question. Please don't leave a 4-point question blank. All right. So y-intercept is actually the easiest one to find. Y-intercept is always going to be 0 and C. Remember, this is A, this is B, and this is C, right? A, B, and C. So for this one, my y-intercept is going to be 0, -3. And I can graph this right on my y-axis there. The next thing I can find is my axis. My axis is x equals negative b over 2a, right? So for this one, negative b, well, that is negative 4 over 2 times negative 1. So I have 4 over negative 2, so my axis is x equals negative 2. And so I can draw that dashed line on x equals negative 2 here. All right. And the last piece of this is my vertex. My vertex is going to be that number that I found there, negative b over 2a. And then what happens when I plug it in? F of negative b over 2a. That just means plug it in. Okay? So my vertex I know is going to have a negative 2 as my x value. And then I'm going to take that negative 2 and I'm going to plug it into my original equation. So negative x squared minus 4 times x minus 3. Negative 2 squared is 4. Then I negate it. Negative 4 times negative 2 is positive 8 minus 3. Negative 4 plus 8 minus 3 is 1. So my vertex is going to be 2, 1, or negative 2, 1 rather, and I'm going to put that right here. Now, while it's not part of the question, you want to consider, is this graph going to point up or down, right? And so how do I know that? How do I know if this graph should point up or down? Yeah, the A is negative, which means my graph should point down. So that means my vertex should be above my y-intercept, right? My vertex should be above my y-intercept, and it is. So that's just a quick check. My graph is going to be graphing down here. And so I need one more point to be able to really graph it accurately. I'm going to use this y-intercept. It is 2 away from my axis. So I'm going to go 2 away on the other side, and I'm going to put a point right there. And that just helps me graph this. So now I know I can do this and down and this side and down, and I have my graph. So if you want to check your Venn diagram for number 1, this is what the Venn diagram looks like. You should label your universal, your A, B, and C, and all the numbers in that as well.